Hey everyone, I hope you're doing well today. In this video, let's talk a little bit about integer exponents. And by integers, I'm referring to positive numbers, negative numbers, and zero. No fractions or decimals. At this point, hopefully you have a little bit of experience working with positive exponents. Here are some examples. In each of these three examples, the exponents are positive. Multiplying 5 2's together, you get 32. Multiplying 3 3's together, you get 27. And multiplying 4 4's together, you get 256. But what happens when you have negative exponents? In each of these three examples, we have negative exponents. What's crazy here though is that 2 to the negative third power is equal to 1/8, 5 to the negative second power is equal to 1/25, and 10 to the negative first power is equal to 1/10. Despite what a lot of people might think, negative exponents don't mean that the values are negative. All of these numbers are positive values. Then you have some situations where the exponent is 0. In each of these three examples, notice how all the exponents are 0. 12 to the 0th power is equal to 1, 4 to the 0th power is equal to 1, and 7 to the 0th power is equal to 1. And at this point, you may be wondering to yourself, what? That doesn't make any sense. How could they all be equal to 1? And that's what I'm about to explain next. In just a moment, I'm going to show you how these positive exponents relate to negative exponents, as well as zero exponents. Let's get into it. If you just want to sit back and relax and see how this works, feel free to do so. But if you want to try them with me, I encourage you to grab some paper, something to write with, and let's do some math together. Let me write down a few examples. Here are a bunch of powers of 2. And notice how the exponents are decreasing by 1 as we go down the list. Let's start evaluating here. 2 to the third power is just going to equal 8. 2 to the second power is equal to 4. And 2 to the first power is equal to 2. So let's try to think logically what makes sense for 2 to the 0th power to equal to. If you think it's equal to 0, think again. Let's try to notice a pattern here. When the exponent decreased from 3 to 2, notice how 8 became 4. Because the base we're talking about for all these examples is 2, 8 gets to 4 by dividing by that 2. And when the exponent of 2 decreased by 1 to become 1, this 4 divided by 2 to become 2. So logically, what should happen when the exponent of 1 decreased by 1 to become 0? Keeping this same pattern, if we were to take this 2 and divide it by 2, this value should be 1. What about 2 to the negative first power then? Well, the exponent just decreased by 1 again, so we should just take this value of 1 and then divide it by 2. 1 divided by 2, that's just going to equal 1/2. Decreasing the exponent by 1 again, we should take this value and cut it in half, and half of a half is just equal to 1/4. And one more time for good measure, what happens when we decrease the exponent one more time here? Well, keeping the same pattern, we should just divide this value by 2, and if you take 1/4 and cut it in half, you end up with 1/8. A couple things that are definitely important that I want you to notice here is that 2 to the 0th power is equal to 1, and anything to the 0th power is going to equal to 1, and I'll show you a couple more examples. In addition, it's important to notice here that 2 to the first power and 2 to the negative first power are just reciprocals of each other. This should make sense because using the properties of exponents, we should be able to say that 2 to the first power multiplied by 2 to the negative first power. Remember that when we multiply things with the same bases, we can just add their exponents. This would be 2 to the 1 plus negative first power. And 1 plus negative 1 is going to equal 0, so it's going to be 2 to the 0th power, and this would just be equal to 1. So if 2 to the first power is equal to 2, and 2 to the negative first power is equal to 1 over 2, what's 2 times 1/2? Well, 2 times 1/2, or taking 2 halves and putting them together, that's also equal to 1. Hopefully that proves why that makes sense. It's also important to know that 2 to the second power and 2 to the negative second power are also reciprocals of each other. If we were to multiply 2 to the second power by its reciprocal of 2 to the negative second power, that would equal 2 to the 2 plus negative 2 power, and 2 plus negative 2 is equal to 0, so that's 2 to the 0th power, and anything to the 0th power is equal to 1. This makes sense because 2 to the second power is equal to 4, and we said 2 to the negative second power is equal to 1/4, and if you would take 4/4, that would equal 1. This seems to also check out. And finally, notice how 2 to the third power is equal to 8, but 2 to the negative third power is equal to 1/8. Just like above, this should also work out. Check this out. The important thing to notice here is that whether you're working with exponents or you're working with fractions, all of our rules should still make sense. And to wrap up this video, let me just show you two more quick examples. Let's check out all these powers of 10. 10 to the third power is equal to 1,000. Notice how there are 3 zeros. 10 to the second power is 100. Notice how there are 2 zeros. 10 to the first power is just equal to 10. Notice how there's 1 zero. 10 to the 0th power is equal to 1. There are no zeros. 10 to the negative first power is going to be 1/10. 10 to the negative second power is 1 over 100, or 1/100th. And 10 to the negative third power is 1,000th. Again, 10 to the 0th power is equal to 1. These are just reciprocals, as well as these, as well as those. The base we're talking about here is 10. And so the pattern is here, as the exponents decrease by 1, the values become 10 times smaller. On the flip side, as the exponents increase by 1, the values become 10 times bigger. If negative and zero exponents were giving you some trouble before, I hope this video helped clarify how they work with each other. Two key takeaways that I want you to have is that when you raise any of these counting numbers to the power of 0, that you're always going to end up with 1. And keep in mind that when you have a negative exponent within a power, it doesn't mean that their solution is negative, it means that it's a reciprocal or a fraction. If you found this video helpful, you can let me know in the comment section down below, and if you go ahead and click that like button, it will exponentially help out this channel. Keep up the great work, and I'll see you in the next one.